Hello and welcome to the Kubernetes Security Challenge Part 3, provided by the KodeKloud platform. So what we have here is a 2-node Kubernetes cluster. We have a control plane and also node 01 on the right of this diagram. Using the Kube-bench utility, we should identify and fix all the issues that were reported as failed for the control plane and the worker node components. Once we're done with that, we should click on the check button to validate our work. Okay, so let's begin at the top where the Kube-bench icon is located. And we should download the Kube-bench from the Aquasec and extract it under OPT file system. We should use the appropriate steps from the Kube-bench docs to complete this task. And the link to the docs is listed down below here. Okay, so let's click on it. And what Kube-bench basically is, it's an open source tool for Kubernetes security auditing and compliance testing. It's designed to automate the process of checking Kubernetes deployments against best practices and industry standards for security, such as the CKS Kubernetes benchmark. What basically does, it performs a series of checks on the Kubernetes environment, such as cluster configuration, node configuration, network policies, authentication, authorization settings, etc. The tool generates a report that highlights any failed or skipped tests and provides recommendations for remediation. What we'll do next is we'll run Kube-bench with config directory set to optcfg. We'll be setting a config file, and we'll also be redirecting our results to an HTML file. We'll be running Kube-bench with the command called run, and we'll be using these two flags. So let's set it now. What a mess. Let's set the redirect correctly. And we don't have a directory called www.html, so let's create one. Okay. And now we can run the test. Let's check if our work was done correctly, and it was. You can move these icons freely if one wants to do so. So let's move on to fixing various issues with the control plane and node components. I'll start with the Kubelet. And what we should do is we should ensure that the protect kernel defaults argument is set to true on the control plane and also on the node 01. Okay, so let me open another console. So we should editing the kubelet config file, which is located and we should edit it and set protect kernel defaults to true. We'll also be setting the same setting on the kubelet node, and we'll do SSH into the node. Okay, so let's do that. This protect kernel defaults argument is a Kubelet runtime configuration option that specifies whether to enable or disable kernel default protection for the containers. And when this argument is set to true, Kubernetes will apply a set of kernel parameters to restrict the container access to sensitive kernel interfaces and prevent modification to key kernel settings. This can improve container security by limiting the potential impact of vulnerabilities or malicious activity in containerized applications. So that's what it does. Right. Let's exit this node. Okay. Let's check if what we did was correct, and it was. So let's move on to the Kube-Controller manager, Kube-Scheduler, etcd, and for our last component, we'll be editing the Kube-Apiserver. So on Kube-Controller manager and on Kube-Scheduler, we should be setting profiling argument to false. Okay. So what in Kubernetes, this profiling support allows you to collect and analyze the profiling data from the Kube-Apiserver, Kube-Scheduler, and Kube-Controller manager components using different tools. Disabling profiling support using the profiling false flag can be useful in, let's say, production environments where the performance overhead should be minimized to ensure that the Kubernetes components are running efficiently, effectively, and without impacting the performance of the cluster. There we go. Maybe it's worth noting that in development and testing environments, it may be useful to enable this profiling support in order to collect performance data and identify any performance issues that may be impacting the Kubernetes components. Okay. Let's restart the Kubelet. Okay. we can move on to the etcd, where we have to correct the etcd data directory ownership. Okay. So data dir is varlib etcd. There we go. So we have a fail at the 1.1.12 check. So either what we could do is this, or we could grab this number. It doesn't matter as long as we get the correct result at the end and fix the issue in a correct way. So we should run the below command, chown etcd varlib etcd. Okay, let's do that. So what this command does, it changes the ownership of the varlib etcd directory to the etcd user and group, running the etcd process as a separate user and group from the rest of the system can also help to enhance the security of Kubernetes cluster by limiting the potential damage that could be caused by an attacker who gains access to the etcd process. Okay. What remains is a Kube-Apiserver component. So let's move on and let's fix these issues. We'll be ensuring that profiling argument is set to false. We'll be enabling pod security policy admission controller and insecure port argument. And we'll be fixing some audit log arguments. Okay. We should ensure that pod security policy admission controller is enabled. Like this. We should also make sure that the insecure port argument is set to 0 on the Kube-Apiserver. This is the option that disables the insecure non-TLS port for the API server. And by setting this option to 0, we are effectively disabling the insecure port and ensuring that all communication with the API server must be done over a secure connection. Okay. Now we'll be adding a few audit log arguments. So the max size argument is set to 100. Max backup is set to 10. Max log max age is set to 30. There we go. We cleaned it up a little bit. And also now, the audit log path flag is used to specify the path to the file where the API server should write audit logs, and to make sure that the logs are persistent and can survive a restart of the API server. The path should be set to a location on the host file system rather than within the container file system. So we'll be adding a host path and a mount path. In Kubernetes, volumes are managing data in container. So containers in Kubernetes are ephemeral by default. It means that their data is lost when the container is deleted or recreated. And to make sure that this data is persistent, volumes are used to store the data outside the container. So therefore, to ensure that the audit logs are persisted on the host system, we need to use a host path volume to mount a directory from the host system into the container, and then specify the path to the audit log file within that directory using the audit log path, as we did before. Okay. Name can be audit log. Let's use a mount path. Let's check if the name is correct. It is. And read-only should be set to false, so that it can write into the log. Okay. Let's do a little bit of troubleshooting. See what the issue is with the API server. Okay. So we made a typo. There we go. Let's wait for the Kube-Apiserver to come back online. There we go. Should be working now. What I showed you there was a little bit of on how to troubleshoot the Kube-Apiserver issues when it won't come up. So that was a bonus. Thanks for watching, and I'll see you in the next video. Goodbye.